Like yesterday, we are still in chapter 11, so I'm going to go over 11.3 and 11.4. The main thing with 11.3 is knowing this frequency distribution thing here. So frequency distribution deals with the joint slash marginal frequency divided by the grand total. So this is where you have your box on the inside and then you have your outsides with your grand total right here. This is talking about, so the frequency distribution and the relative frequency is talking about this bit right here where I've got the two different percentages down the sides. So I've got like all these different things in here, and the chances of this out of this is this much percent, and then I've got this much percent, but then if I go across it changes the percents. So what they're saying here is that your probability percent is going to change based off of if you're using a joint or a marginal frequency, because like I may be looking at two different things here versus here I'm looking at one singular thing. It's obviously going to change the probability percent. So you need to make sure that you're paying attention to if it's asking for joint, which is if you guys have heard anything with this, the first thing that comes to mind with me, but this is of course growing up with a dad as an accountant, is joint filing for taxes. When you file jointly, there are two people involved. Usually it's when you're married, you file jointly. So you've got the one person here and the one person here. So that's why these are the joint ones. So joint means just the two involved. So joint partnership, anything like that, as far as business goes, it's the two people involved, and it's going to give you one of these interior percentages or one of these interior numbers, whereas the marginals, they're out on the outside of the outskirts of all of this data. So if you look at a piece of paper, you've got this red line. Anything over here is considered to be the margins. Same thing with the red line on the other side of the paper. Anything over here is considered to be the margins. And when you're typing up documents for Mr. Landing, you probably, if you've ever printed anything for him, you'll see the whole, it's going to cut off some of the margins. Those are the outskirts, the outliers. So that's what these two are out here. So you've got the bottom one and the right one. So the grand total is always located down here. It's always going to be your total amount or 100%. Okay, moving forward into 11.4, we've got probability distribution. Now this one gets a little interesting. We're actually going to draw a histogram with this because I want to kind of show you what they mean by discrete versus continuous data. So discrete data can be counted, whereas continuous can be measured. The difference between this would have been like, this is straightforward, I have 6 dogs. Obviously, I only have one, but still. I have 6 dogs. I can stand there and line my dogs up and count them. I have 1, 2, 3, 4, 5, 6 dogs. Whereas continuous data is, I am 5'3". Okay, that's not going to be as easy because I can't sit there and count every single inch. I can't say, okay, 1, 2, 3, 4, 5 feet, 1, 2, 3 inches. I have to measure that. So discrete is I can sit there and count it out. Okay, so I can sit here and say that on my table right now I have 4 items. I have my paper, my pencil, my eraser, and my camera lens cover. Okay, so I have 1, 2, 3, 4 items. That's what discrete means. So probability histograms, other than what we've been doing with this, probability histograms are they most often visualize discrete data. So it's usually stuff that can be counted because it makes it easier to get a perfect percentage there. So what we have here is, this is actually from 1970, so don't look at me and be like, I don't know anybody who lives in a household that has 7+ people in it. So this is from the 1970s. So in the 1970s, they actually did a household count, and they said the chances of having this many occupants was this percent. So the chances of one person was 3.8%, 2-person household 7.9, 3 11.6, 4 13.8, 5 14.0, and 6+ was 48.9%. All of that will add up to equal 100%. If you want to see something really, really weird, go to the last page in this chapter. So it starts on page 526, and actually look at this because they show you the difference between the 1970s and 2011, and the data has almost completely switched to where more people were living in a single household and less people were living in a 6+. So it's really weird to me how households have completely changed, but that's off topic. But this is discrete data because they went in and they said, go count the number of people in your household. So a guy living alone in his New York Manhattan apartment looked around and said, just me. Whereas somebody living, well, I'll do me for example, they came to my house, they said, how many people do you have? I counted me, myself, my husband, or I am myself, so me, myself, my husband, and then my 4 kids, which is 6. So back in 1970, we would have been in the close to 50% range, whereas now most of my friends live in a 1 or a 2 person household. I just think it's interesting. Again, so this can be counted because I can turn around and count how many people are in my household. It's not a, well, let me measure. It's not like how tall is the average person in your household. They're not asking that. So we're going to draw a histogram for you. You don't have to draw a histogram, but I wanted to show you a little bit better how it can be counted. So we have the probabilities over here on the left. So I'm going to average this. Remember, I'm going to go over, this should be, anyways, we'll figure this out as we go. So I'm going to go over the probability of having a 1-person household is actually 0.038. So I'm going to do this way down here. So, okay, histograms though, I almost drew a bar graph here. So histograms like to go that far over. Okay, and then I've got, okay, 2 people, 7.9. So I'm going to go up here to about that far. But again, see, I can count how many people were in the household. So this is discrete data. 3 was 11.6, so I'm going to go just above this. 4 was 13.8, so I'm going to go just a little bit above that. Yes, I know my bars are not even, that's okay. 5 was 14, again, a little bit higher up. I know that should still be lower, but I went a little overboard. And then this is 0.48, so I'm gonna have to go, this one's all the way up here. Okay, and you guys kind of get the idea. So this is data that can be counted. And you see why a histogram works really well for this type of materials. So it can be counted. Okay, again, discrete can be counted, continuous can be measured, so counted versus measured, and make sure you know all about frequency distribution. Tomorrow we're going to briefly cover chapter 12, and then next week we will just kind of continue on with reviewing a lot of the stuff. I'll combine it all and mix it up so that I make sure that you guys know this stuff really well. Okay, see you tomorrow.